Greetings. Just wanted to go over very quickly Lab 3. I'm going to do a run through of what was expected for it, where you may or may not have lost points, how it should look, and what your lab should look like for projects going forward. Labs and projects should look like going forward for the future. So let's start off with the software requirements. We will have these for each lab assignment. The bullet points need to be followed. So again, many of these is where a lot of you lost points. Storing all values, anything you use for a calculation in an assigned variable or a constant where appropriate, which is pretty much if you're using a value, it goes in a named constant or a variable. Use your comments. At the top of your program, I'm looking for name of the program, and a short description of what it's doing. A comment for all the variables you use, and meaning would be nice too. Looking at the data requests, anything you ask for input from a user should be user-friendly. It should not smash together. And formatting your output in certain ways. Most importantly, I'll call it the common sense way, meaning if we're working with dollars and cents, you should have 2 decimal places. But let's just jump in here. Let's start writing this and show you what this should have looked like. So again, up top, you have your name. You have the name of the program. And then you have some kind of description of what it does. Now, I'm going to read the description from the programming exercise in the book, but what this should really be is your chance to look at what are the program requirements, what is it asking for, and maybe put that in your own words so you get an understanding of what needs to be done. Many of you didn't follow the simple directions and display all the output that was requested, and that's an issue too. So number 8 is tip, tax, and total. Write a program that calculates the total amount of a meal purchased at a restaurant. This program should ask the user to enter the charge for the food and then calculate the amounts of an 18% tip and a 7% sales tax, display each of these amounts and the total. So take input of dinner charge, calculate and display tip, tax, and grand total. That's pretty much it. Next thing we want to do is declare all of our variables. In fact, actually, let's take a different approach here. Let's start with our constants this time. Named constants. Because the book pretty much told you what you need to do here. You need a tax rate. That tax rate was 7%. This is a named constant. And if you're using all caps, we know it's a certain value that will not change. You do not enter a formula here. A named constant in all caps is a number, a single number that will not change during the execution of the program. It is the book definition. You do not throw the magic number in there in your calculations. You use these named constants. The next one we have is the tip rate. And the tip rate we said was going to be 18%. These will be used in our calculations. And so this is where, when I mentioned initialize your variables, this is what I was talking about. We are going to need a variable for our input from the user. And so we declare that. We not only declare that and see it right from the beginning, but we also set it to an initial value. This is going to be a floating point, decimal point variable because dollars and cents has 2 decimal places. We are not using an int here, we're using a decimal. This is also designated as what we're taking from the user as user input. So when you saw comments on your lab that said did not initialize variables, minus 2 points, this is what we were talking about. Now, that said, I was looking at a rubric for later on in the project. I have taught a version of this class at a different college before and had that in my materials, but it wasn't in the materials that I was presented with the department here. So for this time, we will be giving you those points back at this point. There was 2 points taken off if you got this comment attached to your lab. Those 2 points taken off for part 2, 2 points taken off for part 3. So you will be getting the 4 points back for that if you had this comment saying that you did not initialize your variables. The first 2 of the first 3 labs that I looked at, everybody had these, so the 2 of them had them at least. It wasn't until I was about 8 more in down the road that I was like, why is nobody doing this? And I reviewed some things. It happens. I make mistakes too sometimes. I will admit that. So this is what I mean by initializing your variables. I will be looking for this from your labs going forward. I will be looking for this for your projects most specifically. So let's keep going. What other variables do we need? Well, we need one to calculate the tip. We will need one for the tax to calculate the tax. And we'll need a grand total at the end here. Now, Python is not one of these languages, but many high-level programming languages require you to declare variables at the start of your program. Something unique about Python is A, you don't need to do that, and B, a variable, as we learned, can change types as you run the program. For example, an input can comes back from the user as a string, but we can cast that to an int or a float. Not all programming languages allow that to happen with their variables, and so you declare them in the beginning and you declare their types so you can, again, A, show others who may see your code some of that, but B, keep yourself organized and complete. So there, we have our named constants, we have our variables declared and initialized. Now we need to get our input. So let's just say, get user input. And this would be food, and that will be an input. And that input will have a prompt. Maybe it's enter the charge for the food. We are looking to not have this bunched up. I was looking very specifically for this space. I mentioned it in previous videos. Some of you decided to put a $sign there, and when the input was smushed together with a $sign, that made sense because someone was typing in a dollar amount. I did not take off for that, but you need some kind of user-friendly input. Then we need to typecast this somehow. Now, the input comes back as a string. We are entering dollars and cents, which involves 2 decimal points, so we're going to cast this as a float. That would be your input statement, plain and simple. Then we do our calculations. Tax, tip, grand total. And we have tip equal to food times the tip rate. We have tax equal to food times the tax rate. And lastly, we have our grand total, which is equal to food plus tip plus tax. Those would be our calculations. Now, if you didn't cast your input up here, you could always cast it down here. Like that. However, if you're doing that, you'd have to do it for each one of these. And you're writing it 3 times at that point. Why not just write it once and save some time, save some effort, save the chance for error if you forget a parentheses or forget to do it altogether, and save some bytes in the size of your code. Lastly, we need to display the required output. And again, if I took this description to heart, I have to calculate and display tip, tax, and grand total. So I need 3 outputs up there. So let's do it. Print tip. I'm going to throw a few tabs in here and a $sign. Why am I throwing tabs in? Because that's what I said. Format output such that the numerical values line up. And I even wrote, hint, use tabs. I was trying to make it a little easier on everybody. So there's our 2 tabs. There's our $sign. We're going to now add our tip value, and we need to format this. We need to format it so it only stays at 2 decimal places. Because you are not charged in fractions of pennies, you are charged in dollars and cents, which is 2 decimal places. So we'll do the same thing with text, our tabs, our $sign. We're going to format the value for 2 decimal places. And lastly, our grand total. And again, we're formatting that by 2 decimal places. We'll save this so we can run it. But that's what we're looking for. Your name, program name, description. List out your constants. Make sure they're not formulas. Make sure they're all in caps. Some of you lost points for that. List out our variables. Assign them to some kind of initial value based on what you're going to use them for. These were all going to be floats, so we assign them accordingly. Get your input, do your processing, do your output. And we'll run it. Enter the charge for the food. And you see our output lines up rather neatly in the columns like was asked. And we can run this a couple different times and get the answer that we're looking for. Now, we don't have to have the decimal places line up. That's not what I was asking for. A few of you did, and that was fantastic. We'll learn that feature later, or you can dig deep into the format and see how that works. You did not have to convert your output to string. We've learned the comma for putting values together. Plus, I know some of you tried to use that, and you have to convert things to a string for that to work. But that's what we were looking for part 2, the tip, tax, and total. Now let's look at and try to do the part 3, which was the ingredient adjuster. So again, we have our name. We have our description, or our name of our software is ingredient adjuster. And then we have our description, which is a cookie recipe calls for the following ingredients: 1.5 cups of sugar, 1 cup of butter, 2.75 cups of flour. The recipe produces 48 cookies with the amount of the ingredients. Write a program that asks the user how many cookies they want, displays the number of cups in the ingredient, and for each of the specified cookies. So, get input, number of cookies, calculate cups of ingredients, and display each ingredient adjusted for that number. So we know what we're getting, we know what we're calculating, and know what we're displaying. So let's start this again. We're going to start with our named constants, because the book gave us several very specific ones. It gave us the number of cookies in each recipe, and that was 48. It gave us the amount of sugar in each recipe, and that was 1.5 cups. Butter, same thing, 1 cup. And flour, which was 2.75. There are our named constants. Now we need some variables. We need to initialize them, so we're going to get the number of cookies. This would be an int. Why will it be an int? Well, we're not making partial amounts of cookies. We're not making a fraction of a cookie. We're not making a half a cookie. We are making a certain number of actual whole cookies. So we'll say this is our user input. We have sugar. That's going to be a float. We have butter. We know that's going to be a float because they're all starting off this way. And we know flour is also a float. And you can comment those as well and say what each one is used for. Or variables to represent ingredients and amount of cookies to make. Now I know what your variables are for. Again, there were some labs that I saw that had cookies in capital and cookies in lowercase. Now I understand that all uppercase means it's a named constant and a value that's not going to change. or at least it should. Some of you used capital letters for your variables and gave them formulas. That is a no-no. This helps readability. It is also industry standards for other languages when you're out and about in the world and you're starting to program for other companies with other people, and again, potentially using other programming languages. So let's get our input. That would be the number of cookies. It is going to be equal to an input that says enter the number of cookies to bake. Put our space at the end. I'm going to cast this one more time as well. And we're casting this to an int because we're only making whole numbers of cookies. Now we can calculate various things. And there are a number of ways to do this recipe. You could have calculated the number for each cookie. So you could have said per one cookie would be maybe 1 divided by cookies recipe times the original ingredient or whatever it might be. That's one way of doing it. Another way of doing the calculation would be might be the number of cookies you have times the ingredient in the original recipe, and then divided by the number of cookies in the recipe. There were a few different formulas you could have used. Whatever, you choose one and write out your calculations. If I don't understand your formula, or if you do some weird things with named constants that aren't named constants or whatever, I can at least understand what you're trying to do here a little better if you write it out in text format here with your comments. And that would be the nice way of doing it. I could probably squeeze a few more points from you if I understand your method of thinking as well. So let's just use that alternate second one there. We're going to say sugar is equal to the number of cookies we want to bake times the original sugar recipe divided by our 48 cookies, and we're using our named constant. We'll do the same thing with butter. It's equal to the number of cookies we want to make times butter recipe originally divided by the cookies. And lastly, the flour. Looking, make sure that's all good. The color schemes look fine. So we should be right. Now I guess the last thing to do is display required output. You do not have to use these comments that I'm using. I'm trying to demonstrate for you what I was looking for and what I was expecting as I was looking through your programs. So print, let's see, to make cookies, you will need print, next line, where you need to format these. Now, there was not a requirement per se to format the output here, or the numerical output, a certain way. However, what we do want to make sure is that they are consistent. So if one of these uses 2 decimal places, we want to use 2 decimal places. If one of these wants to use 1, well, we want to make sure that they're all consistent. So I figure, if I can type these right, 3 decimal places is pretty much going to be the max for most of these, considering. If not, it'll round up. Besides, think about your audience. We are making a recipe adjuster. Measuring cups are not that precise, where if you don't format this, you'll have 18 decimal places afterwards. In fact, most recipes are, or most measuring cups are in fractions. And there is functions we could have used that will convert decimals to fractions. But that involves a lot of things that we haven't learned yet as far as importing other libraries of commands and statements that we can use. So that's kind of out of our scope as well. But right now we've learned about format. We haven't learned about round. A lot of you are using round for both programs, and I'm not sure why. I don't even think it's in the book throughout the whole thing. When you look up rounding in the book, it shows you the format command in the 50s, page 54 or 5, I believe. So format is what we have. That's what we know right now. I will never ask anything of you that has not been covered in a lecture video or covered in the book, as far as your reading is concerned. So you shouldn't have to go out of the tool sets that we talk about. So this will be cups of sugar. So just to finish this print statement off. And that's what we're looking for. So they all kind of line up and look good together. Format. The next one will be butter. 3 decimal places for the formatting. Cups of butter. And then print, format, flour. This is the last one. Cups of flour. And we'll look at this code one last time just to make sure everything looks hunky-dory. The color codes line up. I believe that is correct. We'll save this and we will run it. How many cookies do we want to bake? Let's just say 36. It's 3/4 of a batch. And we have some kind of problem. Cookie recipe is not defined. Did I make a typo somewhere? And yes, it turns out that I forgot some S's here. Cookies recipe, cookies recipe. Everything else looks pretty good. Let's save this one more time and we shall run it and see if we can fix this again. 36. And there we are. So for 36 cookies, we need 1.125 cups of sugar, 0.75 cups of butter, and 2.062 cups of flour. And an interesting test that I did, if I run this again one more time, was I was checking for 1. And this is where you get really, really, really long numbers of decimal places. I think there was like 17 or 18 of them, literally. And we just want these to be a little more consistent. Again, most recipes, most measuring cups I grant you, you would not be able to find a 0.031 measuring cup, I'm sure. But you certainly wouldn't find a 0.033333333 measuring cup either. This is what we're looking for here as far as our programs are concerned. If you have additional questions, I encourage you to reach out during office hours, although this week's office hours now have passed and it'll be after the next lab. Send an email. I will set up a Zoom meeting, whatever you need. And then to recap, as far as initializing your variables, I do want to see that going forward. And for this past lab, lab 3, that has already been graded, I will go through later on this week and re-award 4 points, 2 for part 2 and 2 for part 3, since that was not discussed prior to the lab. But we'll be looking for that most certainly going forward. Thank you very much. Good luck to you. And please reach out if you have any other questions about Lab 4.